Chapter 7 is about stoichiometry of chemical reactions. When we write a chemical reaction, on the left side of the arrow are the reactants, that is, the things that are reacting. The reactants are the starting materials. They are the things that we're putting into our beaker or flask. On the right side of the arrow are the products, that is, the things that are produced. The products are the ending materials. They are the things that are going to be left over in the beaker or flask at the end. In addition to writing the types of chemicals in a reaction, we also include numbers called coefficients. These numbers go in front of the chemical formula, and they tell us the relative amounts of each substance in the reaction. If we have a coefficient of 1, it's usually left off. In this equation, we just write CH4 instead of 1 CH4, but the 1 is implied. Since the coefficients tell us the relative amounts of each of the chemicals in the reaction, we can think of them as ratios of molecules or ratios of moles. For example, with this equation, we could say 1 molecule of methane reacts with 2 molecules of oxygen to make 1 molecule of CO2 and 2 molecules of water. We could also say 1 mole of methane reacts with 2 moles of oxygen to make 1 mole of carbon dioxide and 2 moles of water. The ratio is going to be the same if we multiply each of the compounds by 6.022 times 10 to the 23rd, which is the number that goes from molecules to moles. The ratio of each of the chemicals that are reacting is going to be the same regardless of the actual amounts that we put into the beaker. For example, if we have 1 molecule of methane reacting with 2 molecules of oxygen, then we would have 1 molecule of CO2 and 2 molecules of water produced. If we had 3 molecules of methane and 6 molecules of oxygen reacting together, then we would have 3 molecules of CO2 and 6 molecules of water that come out of it. The amounts are different, but the ratio is the same. It would still be a 1 to 2 to 1 to 2 ratio. When we write our chemical equations, they need to be balanced in order for the law of conservation of mass to be obeyed. Essentially, the atoms that go into the reaction need to be the exact same as the atoms that come out of the reaction. If we wrote our equation H2 plus O2 makes H2O, we would essentially be saying that we're putting 2 atoms of hydrogen plus 2 atoms of oxygen in, but only getting out 2 atoms of hydrogen and 1 atom of oxygen. If we wrote it this way, 1 atom of oxygen would be destroyed by the reaction, and that's not possible. They're not created or destroyed, only rearranged over the course of the reaction. In order to match up with what's actually happening, we need to put coefficients into our chemical equations. If we put a 2 in front of the H2 and a 2 in front of the H2O, that allows our equation to be balanced so that we have 4 hydrogens and 2 oxygens going into it. We have 4 hydrogens and 2 oxygens coming out of it. Balancing equations is really a trial and error process. There's not going to be one right way to do it every time, but there are some guidelines that will make it easier for you to balance the equations. The first is that we're going to change the coefficients of compounds first, before we change the coefficients of single types of elements. For example, we're going to save the O2 molecule for last because the O2 molecule only has one type of element in it. When we change the coefficient in front of the O2 molecule, we're only changing the numbers of one element, so that will keep other already balanced elements from being thrown off balance. Our second guideline is that if we have polyatomic ions in our equation that appear on both sides, then we're going to treat them as a single unit when we keep track of how many of each we have on each side of the equation. The third guideline is that we're going to keep careful track of numbers of each element or polyatomic ion as we put in new coefficients. When those coefficients get put in, it changes the number of atoms of each element type in the compound that they're in front of. We're going to keep very careful track of our counting because it is easy to miss something and make a mistake.